good evening. So please join. I already told you for making this class more interactive, starting quiz. So these are the question. This question based on the previous class. So please join and tell your friend to join immediately. Okay. So are you hear me? Are you hear me? Am I audible? Please write in the comment section whether I am audible or not. Please write. Please write. I see three of you are watching this video. So please write whether I am audible or not. Now it is 5. Am I audible? Am I audible? Hello. Okay. So okay, now is it okay? Orko Prabhu or Somavo, please tell me now I am audible or not. Hello, Orko Prabhu, please tell me. Am I audible? Okay, thank you, Orko Prabhu. So this is the question. These are the question. So please solve quickly and tell me the answer of the first. The first question is without computing correlation coefficient, tell the correlation coefficient between x and y. Okay, Shayu. One more thing that our class I so one more thing is I changed my schedule, that is from now the class will be held on Friday and Monday, okay, instead of Sunday, same time at 6 p.m. So what is the answer of first question? And I have received one more thing. I have received assignment from 8 student. That is Swarnabho, Orkoprabhu, Anuswa, Shashwat, Jeet, Shayok, Ronit, and okay, Ronit, Monday. So Tuesday, I think Tuesday. Is it Tuesday is fine for you? Okay. Good evening, Shashwato. So please tell me what is the answer of first question. So please note that I have received only a assignment from a student, that is Swarnabh, Orkuprabhu, Manushwa, Shashwat, Jeet, Shayok, Ronit, and I think Nirmallo. Okay. So I request rest of you, please submit your assignment in time. So what is the answer of why Orko Prabhu? Is it 0? Without computing, please tell me how you will get the answer. Orko Prabhu answer of Orko Prabhu is for first question is 0. So please tell me how you get this thing. Okay, Pritam. Thank you. Orko Prabhu, your answer is correct, but tell me what is the procedure you use for this? Your answer is correct. Please tell me the process. Just without computing, mind it. If you use the formula of correlation coefficient, you get 0. Is it not possible to? I have a problem Monday, Tuesday, Wednesday. Okay, you have a problem in Monday, Tuesday, Wednesday. You see the video, because this video is already in our playlist. Please take the playlist and see the video. Okay. So, Orko Prabhu, I am asking you, your answer is absolutely right, but what is the procedure? So, I think please tell me what is the procedure you apply for solving this question. Orko Prabhu. Okay. No calculation. And difference of the sum of xi and yi are the same. Then difference of the sum of xi and y are same mean what? Sir, I have Pritam sir, I here value of x2 have x2 and 1 have more than one value. So what? For every pair, the pair is 2 to 1, comma 2, 2, comma 1, 1, comma 1. Okay. So, Orko, your answer is correct, but thing is that your procedure may not be correct. Okay. So, thing is, since I the question in the question I mentioned that without computing correlation coefficient or any calculation, just tell me the correlation coefficient of x and y. This means first you draw the scatter diagram. I already discussed this thing in the class. Okay. Then you see that for this data set, your scatter diagram look like that. Okay. Now, if you shift the scale and origin, then you see now it is x dash y dash. Here x dash and y dash is 1.5 and comma 1.5. This is x dash. The origin is x bar and y bar. X bar is 1.5, y bar is 1.5. Now you see that all 4 points equally distributed. The 4 points are equally distributed in 4 coordinates. That is, first coordinate contain only 1 point, second contain 1 point, third contain 1 point, fourth contain 1 point. That means the correlation coefficient of x and y here are 0. Okay, clear? Please tell me, is it clear or not? Ortho clear or not? This is the way. I already discussed this, I think I had second class in the for computing correlation, for finding the formula correlation. I use this diagram. So I just use this diagram and see that all the points are distributed, all 4 coordinates. As a result, correlation coefficient should be 0. Okay, Ronit, please see. If you look at the, are you, is it, I think it is clear, all of you, that the scatter diagram look like, okay, agree or not? Now shift the origin from 0, 0 to x bar y bar. Here x bar is 2 plus 1 plus 2 plus 1, that is by 4, that is 1.5, and y bar is 2 plus 2 plus 1 plus 1, this is again 1.5. Then you see, if you shift this point, okay, fine. Okay, Ronit, okay. So I think it's clear. This point is, this is 2, 1, this is 1, 2, and this one is 2, 2, and this is 1, 2. Okay. Now you see that all the 4 points distributed in 4 coordinates. As a result, correlation coefficient should be 0. Okay. So Shashwata say correlation coefficient implies caution. His answer is false. Why, Shashwata? Give me example. Your answer is right, but give me example. Shashwati, your answer is right. Please give me example. Shashwat, Your answer is absolutely right. Answer is false. It's absolutely right. Give me an example. Number of cars, Swarnabhu says, number of cars produced and number of child going to school would have similarity but are not related. The graph could be similar because if we get high value of correlation coefficient between number of cars going children and no motor car production in last 15 years. Okay. Shashwat says numerically X and Y may have, according to Shashwat, uh, X here number of school going children and Y is number of motor car. Okay, you are absolutely right. I am satisfied with your example. I will give another example after finishing this question 2. Okay, Shashwat, you are right. Thank you. Thank you. Because you see that number of school going children and number of cars, because number of school going children does not imply number of cars, or number of cars production does not imply number of going children, but there may be some there exists some correlation coefficient. Okay, but this is not a, so correlation coefficient may not imply cautions. Thank you, Shashwat. Thank you. So now please tell me the answer of question 2.1. Please answer this question 2.1. Onuswa says question this one. Onuswa, please use Roman. I think you say this. Okay, is it okay or not? Your answer. You answered the question 2 within Roman 2. Onuswa says this answer is true. Why, Onuswa, tell me? Why true? Why true, Onuswa? Onuswa says this answer. Onuswa says this answer is true. This statement is true. Why, Onuswa? Please tell me. Why? So beta yx, say suppose regression coefficient of y on x, that is 1.6, beta xy, that is 0.4. Okay, so beta yx, beta xy equal to r square according to Onuswa. So this is equal to 1.6 into 0.4, and r equal to, according to Onuswa, this is plus minus 0.8. But see, beta yx and beta xy both taking positive signs. That means r should be positive, because sign of r and regression coefficients are same. So answer is 0.8, not plus minus 0.8. But here numerical value is correct, but sign is not correct. R doesn't take plus minus. R should be 0.8. So correct answer is 0.8. Hence it is false. Sorry, Anushka. The statement is false, not true. Okay. Here. Here or not? Please tell me. Anushka, clear or not? So this is the wrong answer. Wrong. Correct option is false. Okay. Because regression coefficient beta yx, beta xy both are positive sign. Both take positive signs. That means R should be positive. Okay, thank you, Anusha. Next question. Now, what about 2 within bracket Roman 1 and 2 within bracket Roman 3? Please answer. Ronit says 2 Roman 1 is false. Why, Ronit? Why? Please justify your choice. And Pritam says 2 Roman 3, this is false. And Pritam use the property that if origin and scale property. So Pritam, please tell me the correct choice. Is it the same correlation coefficient? Numerically same correlation coefficient or not? Okay, we will discuss. Shayok says question 2 within bracket 3 is true because numerically unaffected by change of scale and origin. Yes, Shayok, you are absolutely right. Your argument also right. According to Shayok, he says 2 within bracket Roman 3, the correlation coefficient of 5x and minus 3y is numerically the same as the correlation coefficient between x and y. It is true statement because we know R is a numerically unaffected by change of scale and origin. Okay, yes, Shayok, we are right. So this answer is correct. And Pritam, you use correct property, but we see that the numerical value is same, but the sign is not same. Sign depend on the sign of the scale. Okay. So your answer is not correct. And what about Ronit? First question. Ronit says bxy equal to 1.4 minus byx. So what? see that the sum of two regression coefficient is 1.4 and the correlation coefficient is 0.75. Is it Jeet Ghosh? Please complete your comment. Shayok, Ronit, I do not understand your argument. Sum of two regression coefficient 1.4 and correlation coefficient is 0.75. These two values are correct or not? Please tell me. You say that this statement is false, but your argument is not clear for me. You just write this thing byx equal to 1 minus 4 minus bxy. What do you mean by that? Is it justified your answer? I think not. Please answer 2 within bracket 1 Roman 1 correctly. Please see. Let's see. Since correlation coefficient Ronit said 2 1 is 2. Okay, I think you use fair coin or bias coin, whatever that, I do not know. Uh, if outcome is head, then you use false, and outcome is tail, then you say true. This is not correct way to answer this question. Please give me the proper argument. Okay. R equal to mode of byx plus bxy plus byx by 2. Who say? Mod of what? I know R square equal to byx into bxy. Okay. So, okay, please see. The correlation coefficient R is 0.75, which is greater than 0. That imply with regression coefficients beta xy and beta yx both greater than 0. So we know arithmetic mean greater than geometric mean. This is hold only for the quantities are positive. Here we see that regression coefficients both beta xy and beta yx both greater than 0. So we apply this inequality, arithmetic mean greater than geometric mean, and the two quantities are beta xy plus beta yx and divided by 2. This is greater than beta xy into beta yx whole square, or beta xy plus beta yx. This is greater than 2 into r square. Now, please tell me 2 into 0.75 whole square is what? 0.75, that is 2 into 0.75 means 3 by 4, that is 9 by 16, that is 9 by 8. So this should be greater than 1. But here this value, the sum of two regression, please tell me the correct value. 9 by 8 is what? Or tell me 2 into 0.75 whole square equal to what? Please tell me. That is 8. Please tell me. Is not that 2 to the 2 into r to the power Shayok? I do not understand. This says that it is false because bxy plus byx equal to 1.14 and bxy byx 0. Not 0.7. Correlation byx bxy equal to r square, that is 0.7 whole square. Okay, please check. Or other way, this is 0. See that okay. Shashwat says that GM part will not be. Oh, you are correct. You are correct, Shashwat. Thank you. Thank you. Thank you. Bxy dot byx whole to the power half. Okay. So this means this is r square. So this is 2 into 0.75. So 2 into 0.75 equal to 1.5. So byx plus bxy plus byx is greater than 1.5, but here bxy plus byx equal to 1.4 given. Hence, this statement is not true. Again, I repeat, see that arithmetic mean greater than equal to geometric mean. I use this formula because both regression coefficients are greater than 0, and the arithmetic mean of these two regression coefficients is bxy plus byx by 2, and geometric mean is bxy into byx whole to the power half. So bxy plus byx greater than 2 into r, that means 2 into 0.75, this gives 1.4, 1.5. Correct. So Sayok, you are right. uh, I understand what you say. Jit, please rectify this thing. Jit also correct. Okay. Jit also. Jit is not correct because bxy dot byx is r square. Okay. Jit. Okay. So this means this is not true statement. This is a false. Okay. So this is a false statement. Answer is false. Okay. So now we will going to discuss correlation coefficient does not imply cautions in detail. Thank you everybody for participating in this quiz. Okay. So correlation is right this thing. Correlation for actually right in the way. Correlation does not imply causation a strong correlation might indicate causality but there could be other explanation. It may be the result of random chance, whether where the variables appear to be related, but there is no true underlying relationship. There may be according to Shashwata's example, this is due to some random chances, okay? And there may be third, what is called lurking variable, that makes the relationship appear stronger or weaker than it actually causality means one cause, another is reason. I will explain you. Suppose weight and height, you find weight and height is a weight implies height implies weight, because if your height is increases, eh, then your weight also increases. So this is called causality. Okay, I already defined this term in the in previous class. In the I think in the heading under the heading limitation of correlation coefficient. Please go through it. Okay. I I also discussed here with the example. Okay, are you understand or not with my example? Suppose height and weight. Height implies weight, so this is called causality, because weight, if your height is increases, weight also increases. Another example, suppose rainfall and yield. If rainfall increases, yield also increases. So these are the example of causality. Actually, I mean to say, okay, I define this thing. That is, causality means whether one variable causes the other to occur. So variable height causes the other to occur means weight. Okay, if your height is increases, weight also increases. So height causes the weight to occur. So this is the definition of causality. So I think here I need to write something. A strong correlation might indicate causality, but there could be other explanation. Before, please write this thing here. Okay, please insert this text here. Okay, so it is better to write in that way. However, seeing two variables moving together does not necessarily does not necessarily mean that whether one variable causes the other to occur. Okay, now fine. Sharp, is it fine, na? Please tell me, are you understand or not? So I think Please read it. However, you start with seeing. Now you write this thing. This is why we commonly say correlation does not imply causation. Okay, so this should be in that way. I did this thing. Seeing two variables. Start with this from here. Seeing two variables moving together does not necessarily mean that whether one variable causes the other to occur. This is why we commonly say correlation does not imply causation. Now, start here. A strong correlation might indicate causality, but there could be other explanations. Then you write this 1 and 2. Okay. Now I illustrate this with an example. Consider health data. You observe a statistically significant positive correlation between exercise and causes and cases of skin cancer. That is, the people who exercise more tend to be the people who get skin cancer. This correlation seems strongly strong and reliable, and shows up across multiple population of patients without exploring further, we might conclude that exercise somehow causes cancer. Based on this finding, we might even develop a plausible hypothesis perhaps the stress from exercise exercise causes the body to lose some ability to protect against sun damage. But imagine that in reality this correlation exists in our data set because people who live in the places live in places that get a lot of sunlight year round are significantly more active in their daily lives then people who live in the place, live in places that do not. This shows up in the data, in our data as increased exercise. At the same time, increased daily sunlight expose daily sunlight exposure means that there are more causes of more cases of skin cancer, both of the variable rates of exercise and skin cancer were affected by a third causal variable, causal variable, that is exposure to the exposure to sunlight. This variable is called Larkin variable, but they were not they were not causally related. They are not causally related. Okay, so this is the reason these two variable are competition shows there is a high correlation, but thing is that there is a third variable, that is exposure of sunlight, which is called causal variable or Larkin variable. This, because of this variable, this computation shows there is a high correlation, but these two variables are not correlated, directly correlated. So that is why we are saying that correlation does not imply causality. Okay. So next part, can I rub this portion? Please tell me. Please tell me, can I rub this portion? সহায়ক জিত শাশ্বত অনুসোয়া, please tell me, can I wrap this portion? Again I repeat this thing, I received homework from স্বর্ণাভ, অর্কপ্রভু, অনুসোয়া, শাশ্বত জিত, সায়ক, রণিত, and one more, that is I think his name is Milav or something. Okay, please, I request rest of you, please submit this homework or assignment in time, and please submit homework assignment in PDF format. So some property. For essay or easy computation, easy of computation, we may change base and scale. Base means origin. Base and scale for both the variable that is let u equal to x minus a by c and v equal to y minus b by b. So this implies x is equal to a plus uc and y equal to b plus dd. Now we have n pairs of value of observations xi, yi, I from 1 to n. Then from relation 1 you can write xi minus a plus c ui, yi b plus d vi. So this means x bar, which is equal to 1 by n sum over I from 1 to n xi equal to a plus c q bar. Similarly, we can see that y bar, which is equal to sum over I from 1 to n yi, so again b plus c b bar. So xi minus x bar, this is equal to c minus c into ui minus u bar. Yi minus y bar, this is equal to c into yi minus y bar. I denote this equation by 2. Hence, variance of x, which is equal to 1 by n sum over I from 1 to n xi minus x bar whole square, this is equal to c square 1 by n sum over I from 1 to n ui minus u bar whole square from 2. So this is equal to c square variance of u. Similarly, variance of y, which is equal to, so I think it is D, not C. Please change. Please change. This is D, not C. Okay. Thank you. So variance of Y, which is equal to D square variance of D. This is not yi minus y bar. This is vi minus v bar. Please rectify this correction. I underline the correction by red line, red color. Okay. So this is equal to D square variance of V, and covariance between x and y, which is equal to 1 by n sum over I from 1 to n, xi minus x bar, yi minus y bar, which is equal to CD, covariance between u comma v. So therefore dxyx, which is equal to covariance xy by variance of x, this is equal to d by c into covariance of u comma v by variance of u. So this is equal to d by c into regression coefficient of v on u. And similarly, you can show that vxy, which is equal to c by d v u by v regression coefficient u v u on v. Okay. Second property, from regression line of y on x, we see that the predicted value of y when x is equal to xi is y bar plus r into sy by sx xi minus x bar, which I denote by capital Yi. So this is the predicted value of y when x is equal to xi. Here sy and sx are the standard deviation of y and x respectively. Now sum over yi, I from 1 to n. So this is equal to n into y bar plus r into sy by sx into sum over I from 1 to n xi minus x bar. And this is equal to n into y bar r into sy by sx n into x bar n into x bar. So this means sum over I from 1 to n capital Yi, which is equal to n y bar. This implies capital Y bar equal to small y bar. So this result means that is it implies the mean of predicted of the predicted mean of the predicted values of small y is equal to the mean of the corresponding observed value. From this, it follows that E bar, which is a arithmetic mean or mean of residuals, so this should be I from 1 to n ei by n, and this is equal to 1 by n, and we know ei equal to small yi by capital Yi. That is, yi is the observed value and capital Yi is a predicted value corresponding xi. So this equal to y bar minus capital Y bar, and from the above result we see that capital Y bar equal to small y bar, so this should be 0. This means this mean of the residuals is 0. This means mean of the residuals is 0. Now, property number 3, variance of capital Y. Capital Y is a predicted value. This is equal to 1 by n, sum over I from 1 to n, capital Yi minus capital Y bar whole square. And we know capital Yi equal to small y bar plus r into sy by sx into xi minus x bar, minus capital Y bar is small y bar, because from this result, so this is into whole square. So this is equal to 1 by n, sum over I from 1 to n, y bar cancelled. So this is equal to r into sy sx xi minus x bar whole square, xi minus x bar whole square. So this is equal to r square sy square sx square into 1 by n sum over I from 1 to n xi minus x bar whole square. So this is equal to r square sy square sx square into sx square. So this is equal to r square sy square. So now variance of capital Y is equal to r square into variance of small y. So r square is a variance of capital Y by variance of small y. This is capital is y capital suffix capital Y square, capital is small y square, or absolute value of r, which is equal to capital S by in suffix capital Y, capital S suffix small y. So this implies the numerical value of correlation coefficient may be interpreted as the proportion of the total variability of y, which is accounted for by its linear regression by its linear regression on x. I repeat this statement again. The numerical value of correlation coefficient may be interpreted as proportion of the total variability of y, because see this ratio, variability of y, small y, which is accounted by its linear regression on small x. It can similarly be shown that absolute value of r, which is equal to capital X in suffix capital X, capital S in suffix small s, where capital S in suffix capital X is standard deviation of the predicted value of small x from its regression on small y. The quantity r square is called the coefficient of determination and it may be used as a measure of the usefulness or goodness of fitting, usefulness of the linear regression equation as prediction formula. So if the value of r square is close to 1, this means your prediction equation or your fitting is good and well. And if r square is close to 0, this means your prediction is not so good. Actually, you can explain r square in that way. Suppose in regression equation y18, you can find r square is 0.8. This means 80% of total variation, 80% of total variation in y, suppose your y is weight, so in weight I write instead of y, I use weight. For example, I use weight as a independent variable. Total variation in weight is explained by the independent variable height, say height, through the least square regression equation. Here, dependent variable I denote this by y, which is weight, and independent variable I denote this by x, which is height. That means if you get 80% explanation of total variation of weight via this least square regression, it captures 80% of your data, that is weight data. So I think we are happy if it is get 80% or more. And you see that 20% of total variation in weight is unexplained by height through this least square regression. This unexplained part is error. Okay, understand? Please tell me. 80% is a explained part of which explain this weight via height through this regression equation, and 20% is not explained by height, and this 20% of weight is not explained by height. This is basically error part. Okay, please tell me, are you understand or not? Please tell me, are you understand or not? Please tell me, are you understand or not? Okay, Nirmallo. Yes, I received Nirmallo's assignment. Thank you. Thank you, Nirmallo. 4. Property number 4, that is variance of E, which is equal to 1 by n sum over I from 1 to n ei minus E bar whole square, which is equal to 1 by n sum over I from 1 to n ei square. Since we already knew that E bar is equal to 0, that is 1 by n sum over I from 1 to n. Ei means yi minus capital Yi whole square. I already defined this term. Small yi is the observed value and capital Yi is the predicted value corresponding to xi. So this is equal to 1 by n sum over I from 1 to small n yi. Capital Yi means small y bar minus r into sy by sx into xi minus x bar. This is a small y, a small in suffix small y whole square. Now I break this into two parts, 1 by n sum over I from 1 to n yi minus y bar whole square plus r square sy square by sx square into 1 by n sum over I from 1 to n xi minus x bar whole square minus 2 into r into sy by sx into 1 by n sum over I from 1 to n xi minus x bar yi minus y bar. So this is a capital A suffix y small y square plus r square capital S suffix small y square minus, I write this term 2 into r into sy sx. This is covariance of xy. This term is covariance of x comma y, and this is equal to r into sy sx. So this is equal to r into sx sy. So this is equal to sy square plus r square sy square minus 2r square sy square, which is equal to 1 minus r square sy square. So the standard deviation of E, which is called the standard error of estimate of y from its linear regression on x is equal to capital Sy into 1 minus r square. Since we know variance of E which greater than equal to 0, this implies 1 minus r square is suffix small y square greater than equal to 0. Again, sy square always greater than 0. This implies 1 minus r square greater than equal to 0. Hence, r square less than equal to 1. This implies r lies between minus 1 to 1. This result has of course improved before. Because we use two methods. One is Cauchy-Schwarz and another is I defined as xi minus y xi minus x bar by sx equal to pi and yi minus y bar minus sy by qi, and then I use simple calculation and see r lies between minus 1 to 1. I think it is the second day of our class. Okay. Now, Now from variance of P, this is equal to sy square 1 minus r square, we see that if r equal to 0, then variance of P equal to sy square. So that errors of eliminations, errors of estimations are as much variable as the observed value. And hence the regression line is of no help as the prediction formula. No help as a prediction formula. Okay, I already mentioned that 1 minus r square into 100 percentage is unexplained by explanatory variable. Here we see this thing, variance of E by variance of small y, which is equal to 1 minus r square. This means 100 into 1 minus r square of total variation in y is unexplained by this regression equation or regression line. This is also seen that from the fact that when r equal to 0, we get capital Y equal to small y, a constant. It is also noted that as the numerical value of r increases, variance of E decreases from here. And when r equal to plus minus 1, variance of E is 0, which implies that for each I, Ei equal to 0 or small y equal to capital Y. So that all the points in the scatter diagram lies on the regression line and thus the regression line becomes a perfect prediction formula. From these observations, it is clear that the numerical value of R can be taken as a measure of the efficacy of the regression equation as a prediction formula. We arrive at similar results if we consider the variance of the errors of estimates of x from its linear regression on y. Next property number 5. The two regression lines are okay, Shayok, last line say it cleared that from these observations, it cleared that the numerical value of small r can be taken as a measure of the efficacy of the regression equation as a prediction formula. Okay, Shayok, clear? Can I repeat? Please tell me, can I repeat or continue with property number 5? Okay, the two regression line are y equal to y bar plus r into sy sx. Efficiency. Efficiency means goodness of fit. Actually, I am telling you, if our absolute value of r is increases, that means your prediction model is good. Okay. Because you see, observe that r is nothing but a ratio of HD capital Y, HD capital X, a capital small capital Y, HD of capital Y. R is HD of absolute value of R is HD of capital Y by HD of small y. Capital Y is a predicted value and small y is a uh, observed value. The ratio of these two HD means the efficiency of the prediction formula, that is capital Y equal to alpha plus beta x, where alpha is interceptum y bar minus beta 1 hat x bar. These are the least square estimates. Okay, so that's why this ratio is nothing but the efficiency of regression equation, and again this ratio is nothing but the absolute value of r. So I write this thing, r can be taken as a measure of efficacy of regression equation of a prediction formula. Okay, please tell me, Shayok. Shayok, Shayok, are you hear me? Please tell me, are you agree or not? Can I repeat? Absolute value of r is nothing but a ratio of SD of y and SD of small y. SD of y means standard deviation of predicted value of capital Y, small y. Predicted value is a regression obtained from regression formula. Okay, thank you, thank you. R into sy by sx into x minus x bar, and x is equal to x bar plus r into sx by sy y minus y bar. I denote this by Roman 1 and this is by Roman 2. The gradient or slope gradient of 1 is r sy by sx equal to m1 say, and that of 2, that is gradient of 2, is r into sx by sy. I denote this by m2. Sorry. This should be sy by r sx. I denote this by m2. Okay. So, if theta be acute angle between two lines, then theta equal to tan inverse. We know this formula in our class 12, class 11 or class 12, right? In trigonometric class. Okay, m2 minus m1 by 1 plus m1 m2 equal to tan inverse Sy by Rsx minus R into Sy by Sx by 1 plus Sy by Rsx into R into Sy by Sx, and we get this is equal to tan inverse 1 minus R square by R into Sx Sy by Sx square plus Sy square. Okay. The other angle between the two lines is phi minus theta. When R equal to plus minus 1, then tan theta equal to 0, that is theta equal to 0, and two lines coincides. And when R equal to 0, cot theta equal to 0, that is theta equal to pi by 2, and two lines are at right angle. Okay. Now property 6. The two regression coefficients are Byx equal to R into Sy by Sx, and Bxy which is equal to R Sx by Sy, then Byx into Bxy equal to R square, or mod of R equal to root over Byx Bxy. Thus, numerically, the correlation coefficient is the geometric mean of the two regression coefficients. And the sign of R being the common sign of the regression coefficient. The last property, that is property number 7, since arithmetic mean of a numerical arithmetic mean of a number of positive quantity quantities is greater than or equal to their geometric mean then data mod of byx plus b mod of bxy by 2 greater than equal to mod of root over mod of bxy into byx, which is same as bxy byx, and we know this is nothing but a bxy byx is r square, so this is equal to mod of r. Thus, a numerical value of r cannot exceed the arithmetic mean of the numerical values of the regression coefficient. Again, since byx and bxy are of the same sign, the above inequality gives data of mod of byx plus bxy by 2 equal to 2 into mod byx plus bxy, and this greater than equal to mod r or mod byx plus bxy, this is equal to 2 into mod r. Okay, so yes, Shayo, you are absolutely right. These questions were related to these properties. Okay, you are right, Frank. So I want to stop today. We will continue our discussion, this portion, on Friday at 6 p.m. First 10 minutes for quiz, then second 1 hour for numerical problem discuss numerical problem on regression equation or linear regression line or regression line, linearly discuss numerical problem on regression line and give some assignment. And third portion, that is last hour, second first hour, second 1 hour, we will start discussing on rank correlation coefficient. Okay, so first on Friday at 6 p.m. we will start with quiz. This quiz for 10 minutes. Then first 1 hour we will discuss some numerical problem on regression line and give some assignments. And the last 1 hour we will start discussing on rank correlation. Okay. And again I told you, some of you submit your assignment. The names are, I repeat these names: Swarnabh, Orkoprabhu, Anushwa, Shashwat, Jeet, Shayok, Ronit, and one name Nirmallo. Okay, so please submit the assignment. Rest of you, those who do not submit your assignment, please submit your assignment in time, otherwise you may be penalized. Okay, so please tell me, have you any question or queries on this portion? I will answer you. Please tell me. And first of all, you tell me, are you enjoy the quiz part? I think I want this class more interactive. That's why I start this quiz. So, are you enjoy this quiz part? Yes, yes, absolutely right, Shayok. You are right. So after Friday, will the class will begin on Tuesday at same time 6 p.m. Okay. For this week, I only take Friday. After that, in every week, I will take 2 classes. That is, one is Tuesday, another is Friday. Okay. Okay, thank you. So please tell me, have you any queries, questions? Otherwise, I end this stream. So, have you any question and queries? Please tell me. Any question? Okay, Shashwata. Thank you. Thank you. Thank you, everybody. Thank you. We will again meet on Friday at 6 p.m.